So in Unit 11, we're going to look at recurrent networks and focus largely on a network called long short-term memory network, or LSTMs. To kind of understand recurrent networks, we're going to look at these two resources here. The idea is to look at what are called time series analysis, or data that changes over time. So you might be looking at stock prices that change over time, or we'll look at sunspot data that changes over time. Language, you hear my voice over time. So a lot of natural language processing is actually what we call time series data. Cohen, in his blog here, Colos, talks about if you're watching a movie, humans just naturally take earlier events into consideration when looking at future events, and it's not clear how a traditional neural network could do this sort of reasoning here. So we're going to introduce something called a recurrent neural network. So far we've been doing feed-forward networks. We have some input going into the neural network, and that just goes to some output, and that might feed to another layer here. But we're going to let each layer here feed back on itself. So besides getting input from new inputs, it will also see its past state. Its past state will be returned to it. So every node in a layer will see all the previous nodes activations for that. So one way of kind of thinking of this is to kind of unhook it or unroll this recurrent network. So at the start of a movie or a sentence, you might hear a word that's fed into the network and processed. So maybe the is sent in, and the next part of the sentence, the network is the word network is put into the sentence, or into the network and process, but it also gets the internal state it had before. So we're always getting that internal state. So later on, when we're processing a sentence or stock prices, we'll see not only the newest stock price, but also the previous state of the network. And that should give us some history of it. So hopefully we can maintain some state information here going forward. We do run into some problems with long-term dependencies on these networks. So if we're later on in the movie or processing a long sentence and we're getting to some pronoun here and we're trying to see what kind of pronoun that should be, or some information back. If it's a really long sentence, we have to look back 10, 20 words in a sentence. Sometimes it's hard to remember what the noun or the gender or the number of an earlier noun is to do the sentence correctly later on. Similar to the movie, you might be some movie plot, you see some character again, and you have to remember who that character was long ago, or even in a previous series here. So we have this problem with long-term dependencies here that feed into this. And so you can read through this. Long short-term memory networks try to fight that by making a more complicated network structure here, and in that, rather than having a single activation, we have a number of activations in here and a number of connections here, and much of this revolves around having a state information that flows through, and only on certain conditions does that state information get changed. So if we see some new data here, we will then add to that state information as we go, and then two things get sent forward: the activation and the kind of this previous state. There's more to this, so you should read through these long short-term memory descriptions here to get a better idea of how it works. There's a good walkthrough here. Again, you don't need to know all the details of this, but again, if you're interested, this steps through how these networks works internally. Similarly, this blog from Nicholas talks about the same thing: sequential data, time series data, that sort of stuff, and how we see this certainly in a lot of the voice and speech processing now, and just walks you through the basic idea of a feed-forward network here, and then a recurrent network where we have this recurrent area here, and again tries to do this unwrapping of this, how we get these inputs and move them forward, and some different ways of predicting outputs there. Talks about how backpropagation actually works with these networks, and there's this whole idea of backpropagation through time that backpropagation works with. And then Explode talks about some issues, exploding gradients and vanishing gradients. And this again, vanishing gradients refers to the same thing as before, where when we're looking at information back quite a few time units, that information may have decayed. Or when we're trying to learn that information, the gradients for learning, the amount of change we can apply backwards in time will change. And then it talks about long short-term memories and how that kind of addresses this stuff. This kind of provides a simpler version of a more abstract version of long short-term memory that you can look at also. So we have two types of neural networks: recurrent neural networks, which are simple versions of these recurrent neural networks, and long short-term memory, which are more complicated nodes which try to keep their state better. So that's what we're going to look at in this unit. There's a couple applications. One thing we will see, and we'll see more in the next unit where we actually try generating some stuff, is that these kind of networks, besides just predicting these time series or sequential data, often generated. And so this is some links to some music generation software that uses this time set networks to generate music. In fact, there have been recently an attempt to generate an entire movie with these sorts of networks, so writing and that stuff. Next unit, hopefully we'll look at actually trying to write a story having some, or at least a sentence with these sorts of networks. Now, as far as using these in Keras, there's a couple links in here to describing how we could use these in Keras to predict things. So it talks about the data and how the data set up some of the sequential data, this airline passenger data, and then predicting that data. Talks a little bit about these long short-term memory networks and set up things. We're going to do different examples here, but I thought these might be two examples you might want to look at. One predicts with passenger data, and this one looks at stock data, trying to predict Apple stock prices over time. And again, walks through some of these setups here. So if you're interested in other implementations, these are very similar to what we'll be implementing again, but we'll be doing slightly different ones. So then you'll do your participation activity, and remember to post something to the discussion groups. And then your next assignment, this is actually going to be moving to the next unit, will be generating text, some sentences from these. So hope you enjoy this.